today we're going to be solving one-step inequalities. You know, I love algebra and I love solving equations, and solving inequalities is very similar. Big number one, your job is still to get that variable by itself. So that is your job today. Big number two, always use inverse operations. Remember, addition and subtraction are inverse operations, and multiplication and division are inverse operations. Big number three, follow the golden rule of algebra. Do you remember what that is? That means if you do it to one side, you have to do it to the other. You got to be fair. And finally, big number four. This is something new, so I want you to really pay attention. You always want your variable on the left side of the inequality symbol when graphing. When we get to solving these inequalities, we're also going to graph them. You really want your variable on the left. I'll show you why in a little bit. For example, if you have 5 is greater than x, that means 5 is greater than x. So x is really less than 5. So whenever you have your number on your left and the variable on the right, you're going to flip it. You put your x on the left and your 5 on the right. Because you flipped it, you must change your symbol from greater than to less than. So 5 is greater than x is the same thing as x is greater than 5. Another example. What about 7 is less than x? We want our variable on the left, so let's flip it. That would be x and 7. Your less than goes to greater than. X is greater than 7. Let's look at a few equations, and inequalities, and let's solve these inequalities. Solve and graph each inequality. 3x is less than or equal to 27. We have multiplication here. The inverse of multiplication is division. So we're going to divide by 3 on both sides. Your 3's cancel. You're left with x, bring down less than or equal to, and 27 divided by 3 is 9. So you have x is less than or equal to 9. That means your solution to this inequality is any number that is less than or equal to 9. Let's graph it. Remember, 9 goes in the center, one number above it, one number less than. Is it an open circle or a closed circle? Well, it has equals to, so it is a closed circle, and we're going to shade to the left because it's pointing to the left. So a closed circle on 9 going to the left. You know that any number less than or equal to 9 is a solution. Number 2, x plus 4 is less than 10. How do we get rid of a plus 4? The inverse operation is subtraction. So let's subtract 4 on both sides. Your 4's cancel. You're left with x is less than 10 minus 4 is 6. X is less than 6. So what we're going to do is we're going to decide, is it an open circle or a closed circle when we graph it? Well, it's going to be an open circle because it's not an equal to, and it's going to be shading to the left as well. Put 6 in the middle of your number line, one number above it, one number below it. X is less than 6. Open circle going to the left. So x is any number that is less than 6. Can't be 6 because we have an open circle. Number 3, y minus 5 is greater than or equal to 0. We're going to add 5 to both sides. Your 5's cancel. You're left with y is greater than or equal to 5. We must decide, do we have an open circle or a closed circle? Well, we have a closed circle because it's greater than or equal to, so 5 can be a solution. We also are going to be shading to the right. Let's put 5 in the middle of our number line, 6 and 4. We're going to have a closed circle on 5, shaded to the right. That means, sorry about my shading, it's kind of bad. You know I'm not a good drawer. Anyway, any number for y, a number for y could be any number greater than or equal to 5. So 5 could be a solution, and any number bigger than that. Our last 2 examples. 1 is less than or equal to d over 6. You'll notice here it looks flipped around, but that's okay. We still solve the inequality the same way. To get rid of d divided by 6, we multiply by 6 on both sides. Our 6's cancel, and you're left with 6 is less than or equal to d. If you'll think back to big number 4 in your notes, we always want the variable on the left, so we need to flip it. We're going to put d on this side, 6 on this side. And our inequality symbol flips from less than or equal to to greater than or equal to. Again, why did we do that? So that it's easier to graph. Put 6 on your number line with 7 and 5. It is going to be a closed circle because it has equals to, and we're going to shade to the right. So D is greater than or equal to 6. So the solution for this inequality is any number greater than or equal to 6. Again, this says the same thing, 6 is less than or equal to D, but it's easier when your variable's on the left. Last example, 14 is less than 2m. Divide by 2 on both sides, because that's the inverse of multiplication. Your 2's cancel. 14 divided by 2 is 7, is less than m. We have a problem here because we don't want to graph it until our variable's on the left-hand side. So we're going to flip it, put m on this side, 7 on this side. What does less than flip to? It flips to a greater than. M is greater than 7. We know that's going to be an open circle, and we are going to shade to the right. Put 7 on your number line with 8 and 6. Open circle on 7, shade to the right. What does that shading mean? That means that m can be any number greater than 7. So a solution is greater than 7. Can include 7, that's why it's an open circle. I hope today you practice your inequality graphing skills and we now know how to graph inequalities.